All right, hello class. Thank you for tuning in to our third lecture. So, as you remember from last time, our goal in this unit is to try to understand people's choices by making the assumption that people will choose what's best for them out of their available options. Now, last lecture, we focused on the first part of this, which is how do we understand people's preferences? And we thought about people's preferences both graphically through indifference curves and also mathematically through utility functions and then the marginal rate of substitution. What we're going to do today is we're going to keep building on that by trying to understand people's options, understanding what people's choices are, and then we're going to combine these two pieces of analysis to understand how people make optimal decisions. So to start with, in order to do this, we're going to imagine a really, really simple choice facing somebody, which is we're going to imagine a person trying to decide how much of two goods to purchase. Like peanut butter and jelly, right? And we're going to imagine that they have some income, some money that they can use to purchase these goods. They can only be used now for these two goods. So there's no borrowing, there's no saving. We're also going to imagine that they can buy as much or as little of each of the goods as they want, of course conditional on being able to afford it, at fixed prices. So this means we don't have to worry, for example, about people getting bulk discounts or the price going up if you buy too much. And then the last thing we're going to assume is that you can buy fractional amounts of both goods. So you don't have to decide, do I buy one, do I buy two, do I buy three? You can buy 1.5, 1 and 57, 58, etc. Okay. So what I was thinking about, and I should say, right, this is a very simple environment, but this is actually going to give us almost all of the theory and intuition that we need to tackle some of the big questions and big problems in consumer theory. So this is not a bad place to start. Okay, so when I was thinking about what's a real world situation that looks a little bit like this, the closest I can imagine is walking into a frozen yogurt place, right, a froyo place. We can imagine that you go into a froyo place with a $12 gift certificate, right? That you can only use at this place, you can only use it today, right? It's a one day only special deal, and you're not going to use any other money to buy froyo, right? Either because you don't have anything else or because you don't want to. Now you can use that $12 to purchase two things. You can purchase froyo for 50 cents an ounce, or you can purchase toppings for $2 an ounce. Right, and so this is going to match our assumptions here, right? You can buy as much or as little as you want at fixed prices. You can buy fractional amounts, right, based on how long you hold down the spigot to let the froyo out. And you have a fixed amount of income. Great. Okay, so given these assumptions, or given this situation, let's think about what your feasible options are. How much froyo and how much topping you can afford to buy. Okay, so the basic problem, right, the basic thing that we need to solve is that we can buy an amount of froyo and topping that adds up to anything less than or equal to $12, right? We can spend up to $12. So all we need to know is know how much we spend and then make sure that it doesn't exceed $12. So how much we spend total is going to be the amount we spend on froyo plus the amount we spend on toppings, right? So how much do we spend on froyo? On froyo, we're going to spend 50 cents times the number of ounces of froyo, right, which we'll call F. And how much do we spend on toppings? Well, it's the price of toppings, right, $2 an ounce, times the number of ounces of toppings, which we'll call T, right? And this is the amount we're going to spend. In order for an amount to be affordable, this needs to add up to no more than $12, right? So this is our spending. call this our budget constraint. And in all of these problems that we're going to face, we're going to have a budget constraint that takes this basic form, that looks like this. So in a generic problem where we're trying to purchase X and Y, our budget constraint will be the price of X times the amount of X plus the price of Y times the amount of Y less than or equal to I, which is our income, right? This is what a budget constraint is always going to look like. Okay, so now we need to figure out, given that this is our budget constraint, right, given that this restrains us, how to represent this graphically, what it looks like to have this budget constraint. Okay, so to do that, we're going to draw a graph where we put the number of toppings on the vertical axis, amount of froyo on the horizontal axis. Let's think about what this constraint looks like. Well, first of all, we could think about, let's say that we only bought froyo, right? How much froyo could we afford if we only bought froyo? Well, in that case, we would say 0.5F less than or equal to 12, right? F has to be less than or equal to 24. So the most we could afford, if we only bought froyo and had no toppings, would be 24 ounces of froyo. And if we only bought toppings, right, then we would say, well, now froyo is going to be 0, so we'd have 2t less than or equal to 12, t less than or equal to 6, right? So if we only buy toppings, we can afford up to 6 ounces of toppings. Now, what's the rest of the graph going to look like? Well, to think about that, why don't we try to solve this equation for t so that it looks like a more standard plot, right, where you've got y equals some function of x. So we could say 0.5f plus 2t less than or equal to 12, right, 2t less than or equal to 12 minus 0.5f, t less than or equal to 12 minus, I'll say 1/4 f, right, or 0.25f. Good? So what's this? This is just a straight line, right? This is a linear function, and it's got a slope of 1/4. So what this will look like in our graph, right? We have a straight line here. Now in addition, because there's a less than or equal to, our graph isn't just this line, right? We can also afford any combination below here, right? But we can't afford anything up here. Okay, great. So I want to talk for a minute about the properties of this graph, right? I want us to understand this graph a little bit better. So first of all, let's think a little bit about this slope, right? About this 1/4. What does this slope mean? Well, to think through this, why don't we do this math again? But instead of putting in 0.5 and 2, we'll just put generic prices, right? So we can say PF times F plus PT times T less than or equal to whatever our income is I, right? PT times T less than or equal to I minus PF times F. T less than or equal to I over PT, right? Minus PF over PT times F. Okay, so what does this mean? This is going to tell us that the slope of our budget constraint is going to equal the price of the horizontal good, which in this case is froyo, divided by the price of the vertical good, the negative of this, right? We're normally going to ignore the negatives because everything is negative. So why does this make sense? Why is this the slope, PF over PT? Well, let's think for a minute about what this graph is telling us. This graph is telling us that if we wanted to spend all of our money on toppings, we could get 6 ounces. Right? If we want to spend all of our money on froyo, we could get 24 ounces. And if we started here, and we wanted a little bit of froyo, let's say we wanted an ounce of froyo, we're going to have to give up some toppings, right, in order to be able to afford it, right? How many toppings are we going to have to give up to get an ounce of froyo? Well, an ounce of froyo costs 50 cents, right? It costs PF. So we need to get 50 cents, or PF, through giving up froyo. How much froyo do you have to give up to get PF? You have to give up PF over PT, froyo, or topping, per ounce froyo, right? By giving up an ounce of topping, you get PT. So how many ounces of topping do you have to give up? Well, the amount of money, right, PT times T has to equal PF. So the amount of topping you give up is PF over PT. So what this slope is going to represent is effectively the cost of froyo in terms of toppings, right? So when we have a slope of 1/4, it means that we've got to give up a 1/4 ounce of topping in order to get an ounce of froyo. Now, the reason I'm belaboring this a little bit is because this point here, right, that the slope is the cost of froyo in terms of toppings, is really crucial. It's a crucial insight about budget constraints. And what that insight is that the cost of froyo is not the price of froyo. It's not the number of dollars you give up, because dollars are just a way of getting toppings in froyo. What you really give up to get an ounce of froyo is toppings, right? And in particular, you give up a 1/4 ounce of toppings. So the cost of froyo is actually the cost per ounce of froyo is actually a 1/4 ounce of toppings, right? And the cost per ounce of toppings isn't actually $2. It's 4 ounces of froyo, right? It's the amount of froyo you have to give up to get toppings. Another way to think about this is, if you look at this graph that we drew, toppings are on the graph, froyo is on the graph, dollars are nowhere on the graph, right? There's no dollars here. And the reason is dollars are just a way that these two goods are related to each other. They're not in a real fundamental sense real, right? The only value of a dollar is what you can buy for that dollar. So in a lot of ways, dollars on the cost side are like utility on the preferences side, right? They've got no intrinsic meaning in and of themselves. Even though, of course, we use them every day, they're very important, but that's only because we can buy stuff. Okay, so there's a couple fundamental points I want to make about budget constraints before we move forward. So the first thing is, right, they're going to tell you what options are affordable. They're always going to be, right, the wedge under a downward sloping line when we have fixed prices. In other words, right, it's always going to be the case that we can afford anything that spends all of our money. We can also afford anything that spends less than our money. The third really important point is that the slope tells you how much of the vertical good you have to give up for a unit of the horizontal good. And what that slope is going to be the price of the horizontal good divided by the price of the vertical good. Horizontal, right, over P vertical. Or if you prefer, Px over Py, right? Now, why does this make sense? The cheaper the horizontal good is, the less you have to give up per unit. The more expensive the more expensive the horizontal good is, the more you have to give up per unit. The more expensive the vertical good is, the less of the horizontal good you have to give up per unit, right? Because you're selling more valuable stuff. Okay, so in the next video, we're going to think a little bit about how changes in prices and changes in income are going to affect this picture.